We're studying data structures, WIA1002 Lab 2. It's in this class, we'll just be looking at the questions and answers for the labs. I'll explain the answers. We'll go through the questions, we'll go through the difficult parts, we'll go through the code. If you have any doubts, you can share them with me afterwards. This question is all about generic classes. The topic today will be understanding the most basic type of concept in data structures, which is generic class, a generic class. Now, if you look at this public class stone pair, generic, well, first you have a store pair. You have some things, you have first, second as a private integer attribute. Okay, then you have a constructor. Fine, you're assigning the values, you have getter and setters. And then you have something to convert into string. Now, override the object equals method in the stored class to compare the first two values of the object's equality. Now, the equals method is used for comparing objects. The condition for equal can change, okay? The criteria for equality can change. What does that mean? What that means is that different things have different ways of being compared. Comparison can change. So let's say if you have integers, you, well, just make them equal. Fine, that's easy for integers. But if you have something else, not integers, let's say two cars, how can you compare cars? You can't just make them equal. We could say if two cars have the same name, then they're the same. But that's not always true. Are not always the same, even if they have the same name, because the models can be different. So then we say, okay, the model and the car name have to be same for them to be equal. But that's also not always the case. Sometimes you have the same year, same car, same model, but they're obviously different cars because, well, different people own them. So we could say if rather than all of this, if we say car one or car, we could say, we could take two things. We could compare this dot car, this dot license registration number or license number is equals to the car2 dot license. And if this is true, then you can return true. So this line here, it's this dot license equals car2 dot license. You would say equals, and now you would, rather than taking an integer or something, here you would rather take car car2. So you're passing an object now to compare two objects. Okay, this is the method. Let's try that. Let's do that. Now we're doing lab 2. Let's go to question 1 of lab 2. The first question, you need store pair, right? Equals method. Okay, now let's get the questions. This is the code which we already had. Now we're overriding compare to method here, and the equals method, and the toString method. All of these are overrides because you're changing the behavior of a function which used to exist already. Now, public integer compared to, okay, well, we're not doing that yet. We're looking at the equals method, which is here. So as you saw, object, another object, over here did object, well, car2, same thing, but you're not passing car because in this case, it doesn't have to be specific to our car. You could just pass any object of another type, any object, and then you could compare those. Now over here, it's important that you're passing a car. Uh, so you could write car2, and that's what's passed. You could do that there, okay? Or you could allow anything to be taken as a parameter, but then check if that's an instance of the same class or not. Car would be the same instance as this dot license because this here is a car class, right? So if you're trying to compare cars, the object which you're passing should be a car. If it's not the same type of the class, obviously it's not equal. So we can just directly return false. This is good because it allows you to compare strings and integers or, well, there is no comparison because if you pass a string object here and then there's an integer object which you're trying to compare with, it would directly say, no, these are not the instance of the same class, and it would return false. So you check if is it the instance of the class you're trying to compare with. If yes, okay, then you can proceed with the um, comparison. Now store pair, another store pair, another object. Now why do we do this? Because we want to we want to typecast to the correct class. Now this will just allow will prevent any compatibility issues. So for example, a child class, okay, you could have an object which is let's say an object which is an instance of the child class of stored pair. Now, once you have this another object, you return another dot get first if it's equal to get first. Now, what is this? So what you're doing here is that you're comparing the first number of the pair. If the first number is equal, then they're equal. Okay, and it's the criteria is given here. Compare the first of the two values. If they said second, you would just do get dot second. Or if they want both the numbers to be same, then you would compare both. You do like an AND condition. Okay. Okay. Moving on. Next part. Have the stored break class implement the comparable interface. Override the comparative method. Method compare the face values of the two of them. Now comparable. This is just for equal, right? Equal means if they are similar, if they're the same, exactly the same. But compare to uh, can give you some sort of difference between them. It allows you to compare two objects. Moving onwards. So you see this dot get first minus another dot get first. It subtracts the two numbers and allows you to get a numerical difference between them. So then you can rank your objects. Now, to get a comparator, you need to have the comparable class implements comparable, and these two things are called generics. This thing, it's a diamond operator, and this whole thing is a generic class. Generic because it allows you to specify the data type later on. So over here, the data type is store pair. It's you're implementing compare. Do not forget these syntaxes. You need to memorize them. Now, then it's easy. You just return the difference. Very simple. It's quite easy. Create a test program that creates three objects of the store pair generic class A, B, C. Then the first is okay. You're just making a tester class, basic stuff. Okay, if you look at the tester class here, we'll just name it neutral. We have our generics, fine. These objects ABC done. Invoke the compare to and equals method that compares. Again, we've done that here. Okay. You have some errors. Let's try and fix it. Class store pair. Okay. Oh, we need to change the name. We need to make it generic. Okay. Now, what changes do we need to do to make it a generic class? I mean, it's quite easy. Very simple. So first, let's obviously change the name to generic. Implements comparable store pair. So comparable. Now, it's generic, right? That means it's, well, not any type yet. Let's say type T. Okay. So we will specify that this guy is type T. Okay. And extends the class comparable of type T. Now it implements comparable as well, not as store pair, but as type T. And well, not just type T directly, but store pair type T, because it's comparing the store pair class or whatever the type was chosen here. So you can choose the time when you're specify. You can choose the type when you're creating the object. Now, these won't be integers, but type T. T is specified at compile time. Now, store pair generic. Again, this would be T. because, well, it's not an integer class anymore. At first, again, this will be returning t. This will return t as well. So we change the data type. Now that's done. Uh, it's a generic type t. Okay, you could use any letter, it doesn't really matter. You could say K, F, M, it doesn't matter. Now, hmm, this won't always work actually, because it depends. So sometimes if it's not possible to subtract them, it would give you an error. Now, by default, a compare to class method would give you the difference between the objects. Rather than writing this, we can just call the superclass like this. Now, for this one, that's done. We can check one more thing. Now we don't have store pairs, right? We have type T. How do we compare if the another object, the another object is the same as the object which we're dealing with? So we can do something like this. Uh, we can do another object of get class is not equal to this dot get class. And if these are not equal, the classes are not equal, then we can return false. We can also check if it's null. This is correct. What else? Now we can also directly check if both the objects are the same. If they're exactly the same, then obviously they're equal. If they're like everything is the same. That means the first and the second number are the same. So it's a shorter way of writing it. But the question instead is not asking us about that, but they're asking us to rather compare the first number. So we'll do that here. This will be false if the second number is not the same. This. So then we check the first number. This is sort of like the default case, because if this is true, then that means those both the classes have the exact same digital footprint, basically. If they're not exactly the same, it's not null, and the classes are, well, not different, then we check the first number. If the first number is same, then you print true. Done. Let's try to run it. There's some problems. Okay. What are the problems? Store pre-calculated integer. Let's see. Do we have some issues here? Oh, it's integer. See, int. Let's check. It should be integer, not t. That is correct. That is fine. 51. Let's see. Um, our comparison class. So in the comparison class, we check. We just do another dot first. Oh, we forgot. It shouldn't be t. It should be store pair generative. That's what we're comparing. Let's try it. Okay, now Q2 Java. This should be, oh, it should be Java 2. And the name of the file is, well, wait, we're doing Q1, right? That should be Q1. Now, 36. Debugging is a big part of programming, to run away from it. Most of these are quite simple stuff. It's you will face errors when you're dealing with data structures, but you need to be able to go through the errors and try to fix them one by one. That's the whole goal. But they're not fine simple. This is unchecked or unsafe operations. That's just because you're using generic classes. That's fine. So let's check the compare to class. Compare to is fine. Now, the string is fine equals class. If another object is null or another object or get class is not equal to this dot get class. Oh, it should be a method. And we're done. Let's run it. Okay, so first one is we can compare. So B, A compare with B, A with B. So get a positive integer here because A is bigger than B. 6 is bigger than 2. That's why it's positive, plus 1. Compare to just gives you a comparison of the positive, negative, or 0. Negative means smaller. 0 means equal and positive means bigger. So A is bigger than B. Yes, 1. A is equal to C. Yes, correct. B is equal to C. No, B is less than C. Yes, minus 1. B is less than C. A equals B. A equals B. No, 6 and 2. No, false. A equals C. Yes, true. B equals C. False. Done, moving on. Question 2. Create a generic class called myGeneric that accepts one parameter, declare the variable called E for the type parameter. Create a no out constructor. Create a constructor that accepts one generic parameter. Section get a method for the generic set. Create test related creates two instances of the generic class of the type string object of and type int object. Set a value of each of these objects, display values, and the get a method. Very basic stuff. Let's try it. Now, why you need generic? Because your linked lists and stuff need to be, linked list of integers, linked list of strings, and so on. Question 2. Basic stuff. You can see you have my generic E, private object E. My generic, it's a default constructor, no parameters. Public, you retain you set the object, you get the object, you set the object. Simple. And there are two constructors, one parameter and yeah. And now we need to test this. So we tested a string type, integer type, int object, string object, basic stuff. You just have to write it here. You don't have to write it here as well. If you do, it doesn't make a difference. Set the object, then you get the object. Fine, let's run it. Okay, done. Simple stuff. In a class called compare max, create a generic static method called maximum. Okay. The generic type extends the comparable interface, which receives three parameters. Find the maximum of three values invoked by the main method. Maximum of the three values. Basically, you're trying to get the maximum between three values. And it's quite easy. You have to compare max method. It extends, well, yeah. You have a compare max class, and then you have the maximum method. It extends comparable, and it finds the maximum of those. Now, compare the three objects again. These are different types of methods, implementations basically. You have maximum, maximal, max. Just different ways of doing the same thing. Okay. Now we need a tester class. Okay, let's try it. You have your test function here. We're just comparing different methods. That's it. Different types of doing the same thing. You can see the code here. The first one. This is the most basic one, right? This is a bit shorter, most efficient, you could say. Then this is another one. Now, we're also checking the time it takes to get it done. Right? Let's run it. You can see the codes once. There's two public classes. This one, we could change it. We could just do basically you sort it out. Try it again. There's some actually. Okay. We didn't import the things. The first one takes a lot of time. Second one is shorter. The last one is the shortest. For this one, yeah, last one is the quickest one. That's time complexity as well. You can check the speed of your code. How do you do it? You have a start time, system.out time, and then end time, and then you print the time years. End time and start time. Okay, just look at this, and this. Now, next question. Provide a declaration and implementation of the generic method, min-max, that takes in an array of generic types, returns a string with the following format. Min value, max value. For instance, in your main method, create one object of the type array if integers and one object for type string. That's simple. So you're just comparing. See, um, that's the minimum. The minimum here would max would be tan and min would be blue. Now that's just the order, alphabetic order here, alphabetical order, and the numbering order, the ascending order. The minimum would not be five, but one. Okay, let's try it. We'll change this. We'll just convert this into the not natural order method. Okay, let's see what's happening. So, oh, okay. Min is equals to blue, max is tan. These are the times used. Min is 1, max is 9. This is the test case. You can try solving some lead code questions on this as well, just to improve your understanding of the concepts. Now, question 5, find max class that contains the following. A circle class, okay, indicate the radius variable, okay, fine. This is quite basic again. You have a circle class which has certain attributes, right? Um, Radius attribute, and then you test it with the max method. Let's run it. Let's get our circle class, this circle. Hmm. Okay. Before we do that, let's do that. Okay, works. Next, we need find max class. It has the max method. Okay. So far, everything works. Next, we need a tester class. Okay. The max, the main int array is, well, at least in this case, we have 1, 2, 3, red, green, and blue. Then you have circle. Hmm. It's 3. The biggest illness is 3. This is Q5. So that's 3 for the first one, red for the next one, and 5.9 for the other one. Last question. In a class called min-max 2D array, write two generic methods. 2D array, find maximum in a 2D array now. And then you test it. Very simple. Okay, it works. If you have any questions, you can just message me. You can speak with me in person as well. You can email me. Just go through the questions, go through the code, try to do it yourself. If you have any doubts, please clear it out. Now, let's look at this question. They want you to just implement a min and max method for finding the minimum and maximum in a 2D array, 2D generic array. Fine, that's easy. We have there's the comparable class. Fine, if it's null, just return null. Easy. Okay, you have your 2D array there. You fill it up. Done. This is for minimum, that's for max. You compare, updating the maximum. Then this is for passing the values of the array. And finally, um, you test it with the two methods. Now, for the interface, why do we need this interface here? The reason for that is because before we do that, what is an interface? Not just a blueprint for a class, right? That tells you the methods which you can apply, which you can have. So this interface, the two-dimensional array function, it allows you to have, well, it has the apply method, right? When you do it with a 2D array, right? That's the change which you're making. This will allow you to have different types of implementations for the min and max function. Okay. Now, where do we use this? You can see it. We didn't use it here, but we could use it. Yeah, you could use it something like this. I'll show you how to use it. Look at this. Okay, so you're using apply. Oh, what do you see? Apply. You're passing the array to it. So this allows you to create, or it allows you to use the function, the method of this class. Very cool, right? You can use the method of a class and declare it. Perhaps you could say instance of the method, not an instance as an object, but the method. And then you can apply arrays to it. That's it. So we're done for today. If you have any doubts on this, please go with the code. Do it yourself. If you run into something, if you don't understand everything, just ask me, and try to make sure you understand each and every line here. If you don't understand something, uh, experiment with it, learn it, Google it, and then obviously ask me for doubts, because everything here is something you need to learn. If you don't learn it now, you'll face problems afterwards. That's it. That's all for today. I'll see you in the next lab.